My name is Ziad Kallab. I'm a member of the Office of the CTO at Riverbed. And, well, first, the good news. I actually have no slides to present to you today. So it's a relief from, it's a bit of a change of place. I do intend to use a whiteboard, but for the most part, I would like this to be a talking discussion. Let's have it to be very interactive. So, all right, so what initially, when I wanted to present to you, I titled the session Reality versus Perception. But Romain convinced me to change it to become, enterprise use cases. I was okay, and I settled on SD-WAN enterprise use cases. And here's why I wanted to change it up to be more around the reality of it. Because let's take a look back as to where SD-WAN was from inception and to where we are today. When SD-WAN first started, who really picked it up? You have your internet use cases. You have your possibly your simple retail, but it was mostly the use cases where they had that one WAN, that one cloud, being composed of the internet. So most of the customers were doing a direct one-to-one replacements of what they have. So, for example, if they have firewalls setting up tunnels back to the master hub, or if they have these secure routers, setting up tunnels as well. And what was happening with SD-WAN is we were taking what they already, a one-to-one replacement of what they had and replacing it with these new gateways, accomplishing the same role. For the most part, that was the easy, non-complex use case. You had a group of maybe possibly 10, 20, 30, 40 sites, and that was easily to get done. Why? Because you had one overlay to worry about, and you were just kind of moving on from site to site. But now, what do we have today? The market has shifted. And now what we are seeing more is that the enterprise is wanting to pick up SD-WAN. But the enterprise is actually a different market than the previous market that SD-WAN was in. Now you're trying to layer a new topology on top of an existing topology, as well as adding in a whole new wide area network, which possibly could be composed of the internet. And you're trying to route all across it. So you have, on one side, these enterprise level engineers who are exceptionally bright. They know their code, they know their configurations. They've been at it for quite a long time, and they're trying to adapt using the ways of the early adopters into their existing environments.
Could you qualify that? You said you're layering a new topology on top of an existing topology, but I would say that the existing use cases is still primarily taking the WAN you've got and replacing it with SD-WAN, more like that initial use case you described. So what specifically can you cite that is that layering on top of existing as opposed to a replacement?
In the original days, in the first few days of SD-WAN, or is it the today's market?
No, the second thing you.
The second market, yeah. So the second market is that you have where you start to introduce the overlay on top of the underlay, and that's what I meant by that. So you have this new encrypted SD-WAN fabric, if you will, running on top of the underlay, the existing routing that we all know. For example, meshing in an MPLS cloud. So what we have seen in the market is that you've got these two networks running concurrently at the same time. This may be different, maybe because from different competitors as to how they have approached their SD-WAN solutions. And so you're running one on top of the second one.
In other words, people are keeping around their existing private MPLS infrastructure.
Exactly, yeah.
Point you're making.
So this is
not a migration to internet as WAN exclusively.
Exactly, yes, yeah, that's
MPLS
exactly what I meant,
internet.
yes,
Okay.
yes, exactly, yes.
Yeah, I would think of it as, this is maybe a blinding flash of the obvious, but when you had MPLS running with tunnels over the internet, you had the IGP, EGP mess, and so then layering a tunnel and running your IGP on both sets of tunnels simplified things considerably. So
So, because not everybody is, remember, not everybody is moving to internet only. It is eventually we are gonna, I believe we will get there. But concurrently at the same time, what do we have now? Is that you have to maintain a network to maintain that attachment to your existing, sites, which the traditional routers, which what we are calling the brownfield situations. Right? And then you're layering in this new technology, this new feature on top of it, as well as introducing internet as a transport. So the enterprise is really bringing in a multitude of, it is introducing a number of new use cases to the environment, which are vastly different from, hey, I'm internet only, that's what I want to stick to, right? So now you've got these engineers who are trying to figure out, okay, if somebody was able to do it in an internet only, why was it so simple for them? And then they try to use it in their existing networks, and they're not seeing the same results. And this is where that perception, kind of starts to collide with some of the reality. Show me the orchestration of what you've been able to do, on top of now in my enterprise. So, for example, some of the early things that we ran into, quite obvious. For example, on the internet, you're not feeding in a default route. You're not feeding in, supernets, for example, that you have to worry about. But then in the enterprise, we start to see all these new prefixes come in. Okay, now what do we do with it? How do we take care of it? How do we send the traffic? Remember, the use case in the enterprise is not just the branch, where it's quite much simpler than what you want to do at the hub site. The branch, for the most part, is it's much simpler. You place something at the edge, and you're able to just front-end it, separate those two networks. So we've seen that through happen through Riverbed, and there was a change in the market in terms of the vendors of what they wanted to adapt to what their customers were asking them to do. So the vendors started to add more knobs into their SD-WAN fabric by enabling new, really there are traditional features, but in order to be able to connect and adapt to enterprises. The problem there that we saw is there was a move away from the true SD-WAN, the true DNA of an SD-WAN solution.
What is that?
So, for example, just by being able to bring up a knob, being able to allow you to putting a UI, replacing a CLI configuration, I myself do not call that an SD-WAN solution. Just because you allow me through the UI to be able to manipulate or maybe let's say, for example, add a static route,
Little bit.
it's still part of taking in the background, taking that UI, turning it into a CLI and being able to push it.
Yeah, but it brings simplicity, right? Also.
Just from the UI perspective, yes. But what about what else you wanted to do? What about what is more the intent behind it? And furthermore, that simplicity part, what is the effect of it that it could turn onto a network? Is it damaging to the network? Because it's so simple now to add a static route, or maybe because it's so simple now to be able to introduce new networks or to change the behavior. What are the consequences of that event? So we have to take that into consideration when we're turning on an SD-WAN solution.
Okay, but what is the consequence of just using UI versus CLI? If static routing, just static routing.
But what if we're just looking at it from a perspective of an enterprise, right? How often are static routes only used, right? So you have to take that in consideration a bit more of a holistic approach. Okay, throughout the overall solution, what are we trying to do?
Yeah, but from the branches, we almost, you said what's the use of static routing, right? And most of especially MPLS L3 VPN solution, even providers don't allow using other than any routing protocol, static routing or BGP. So, which means static routing always there, especially for the branches.
But
We've seen some design issues. I think I'm sort of getting it, but maybe not the specific case
so
you're
there's
referring to. What we've seen is with a competitor, the customer had some MPLS sites, but the controller was internet attached. So they had to leak routes between the underlay and the overlay to get the MPLS only sites to the controller. and the provider that set it up unfortunately leaked everything, so they totally messed up the routing.
You have to take care of it to watch out, okay, what else is it doing? How much more, what is the effect of that, what I'm doing? So this part of it actually is why at Riverbed, we are challenging the market a little bit in our approach. And this is kind of, what sort of, Gartner termed it as, we're challenging it, is that, okay, let's try to maintain some of that, SD-WAN profile into the solution. So in whatever we do, let's make sure that it's done right, and let's make sure that it's done safe when we're doing it. And let's maintain some of that orchestration that, that when it's done and when it can be applied. And we want to also do it in an elegant way so as to maintain that simplicity of SD-WAN, maintain that simplicity of the UI, but still in the background, try to obfuscate as much as we can while doing it in a safe manner. So, so one of the use cases that I wanted to start to talk about is that we're introducing is what we're calling internally we're calling it topology discovery. But really, what that is, it is the overlay fabric and what we can do with it. So what we have done is we have cleanly separated the overlay from the underlay. We have given you the power. We have given the user the power, and via simple configurations to be able to sort of create a gatekeeper between the overlay and the underlay, in terms of what we allow into the overlay fabric, separating while maintaining that separation from the underlay. So as an administrator, you have the power, just like how, for example, using access list, in order to allow in what networks to participate in the SD-WAN fabric versus what else you want to maintain in the underlay. So this goes back to your question, is that, okay, we've got the over and the under, but now you're allowed to bring in those same identical networks from the underlay. You can now expose them to the controller in the overlay.
So you sort of fade from MPLS only to MPLS tunnel over MPLS.
MPLS tunnel over MPLS.
Incrementally.
Exactly. Yeah. So you're able to bring in as, for example, just like an access list, you're able to, bring in everything into it if you'd like. You can bring it in based on an interface. But you can bring it in based on what you're learning dynamically from a protocol, whether it's OSPF or BGP, and allowing all those networks that you learn to participate in the overlay. Or at the same time, you can restrict them all to maybe a certain subnets that you want to.
So you are doing MPLS over underlay MPLS VPN service to me?
Well, over whatever the WAN cloud is.
Okay.
If it happens to be an MPLS.
On top of that MPLS tunnels you are.
No, we're not running an MPLS on top of an MPLS. We have our overlay, right, which is running on top of the MPLS cloud, and that's what we're calling the underlay, right? So in that, all those routes that are in the overlay are controlled by a central controller, and it has the knowledge of all the networks, where they are, who owns them, and it only is able to learn about the networks that it knows those are the SD-WAN networks. Those are the ones that it wants to participate in. So for example, in the use case of running a proof of concept for a customer, you may attach via, let's say, OSPF to their network. You're going to end up ingesting and learning about all the routes that they are advertising to you. From a simple perspective, okay, just attach in that area, okay, and learn all those prefixes, all those networks. Now, you are able, even though you learned all these networks, you're able to say, okay, I'm only interested in these specific subnets. Those are the networks that I want to let my SD-WAN advertise. So that way, at the remote site, traffic that is interesting becomes only composed of these certain subnets. So now we're able to introduce SD-WAN into existing complex networks without really affecting the remainder of the subnets. Maintaining the whatever is existing can still traverse the previous traditional way without having to actually replace, let's say, the CE router that they have at that location.
So one perspective is that when we've done a conversion, admittedly in a slightly different context, we did old and new. So we had sites that were on VPN, and IPsec VPN and MPLS, And when we stood up the new, it was tunnels on both flavors, and then we used data centers to interconnect the old and the new and keep things clean. Experience suggests that it's a really bad idea to mingle underlay and overlay unless you have some sort of control.
Correct. And that's that topology discovery is what lets us to have that control, what we want to allow in, what we don't want to allow in. You can be as specific as you want and as open as you want. But just like, for example, the nearest context I can relate it to is something to do with blind redistribution. You never want to just blindly redistribute an entire network onto another one. The consequences of what could happen are just it's just going to cause disasters. So you want to be controlling in terms of what you are distributing from one network onto another. Same concept applies here, is that now we're able to control what goes in as we migrate. So now when you are fully migrated, then if you want, you can certainly just enable everything to be, because now everything is overlaid. Right? It's that, it's sort of like that meshing of the two islands, if you will, which has been referred to in the SD-WAN world. You've got the old island, you've got the new island. How to mesh those two islands together? That's sort of that concept, is that we're able to keep them apart, but then bring them in, as on an as-needed basis. So
you mentioned, sorry to interrupt. So you mentioned the controller. So is it something that is in the cloud, that is in Riverbed cloud, that can be in AWS, or that can be in a data center at premises, or?
You have your choice of how you want to do the deployment. You can certainly deploy it, in the cloud, or you can deploy it on-prem.
Okay.
So it's just depending on the approach that you want to have.
So is it in the customer cloud, or is it in your cloud, in a Riverbed instance that you guys own?
Riverbed managed owned instance.
Okay.
Yeah. So which we run for you, we'll manage, and we've got the SLAs around that. Okay. But if it's something that you desire to have it on-prem, you can certainly move that to on-prem to your own liking, whether it's your own, to your own data centers, your own, if you want your own cloud instance. But certainly just the models, it just depends on. Yeah. But both are available for you.
Thank you.
Yeah. So really what we saw from that example, from that what we did at that customer, is that we were able to limit the scope of the POC, to limit if there's any traffic interruptions, for example, while the customer wanted to get the feel of introducing SD-WAN into their environment. So now that we've got this, what I'm calling this sanitized overlay, right? And we've got the underlay also that is still there. Let's see what else we can do. We have the concept of the overlay routing table, and we've got the concept of the underlay routing table, right? They're both separate, but what we've allowed you to do now with our software is that you can actually merge them together if you want to. So you can take the overlay routing table and introduce it to the underlay. When you do introduce it to the underlay, the same traditional knobs of redistribution are still available for you. So for example, you can apply route maps, you can apply filters, you can apply any kind of the attributes that you want, just according to that protocol, that how you are redistributing it back into it. Now, what does this redistribution do to you? Is that now it gives you the power to start, for an enterprise, it gives you that capability to be able to start to bring in that SD-WAN island onto the traditional portion, which is still owned by the traditional routers, that brownfield type of scenarios. Because a typical enterprise, you're not going to be able to migrate, for example, 50, 100 sites in one night. There is no big bang when it comes to SD-WAN. It's just going to take some time, and that migration is what has been painful that for many customers. And I know we've heard about that throughout the chatter on especially like around in many blogs, and is that is SD-WAN really it? Is SD-WAN is it able to complete the promise of it? And we've heard about that. It's because that some of the challenges that we have endured, but we're able to now give you many of those knobs to be able to integrate that into your existing environment and be able to mesh those two together. So so we've got the capability now to bring the overlay into the underlay, and being able to have many of those what the filters that we want to apply to be able to minimize, the exposure of what we want to do with from the overlay in terms back to the underlay. So, for example, a typical use case there that we have seen from our customers is if they have multiple different MPLS providers. And let's say in certain region where one predominant MPLS provider exists, they started to bring in that overlay, converting the sites into an overlay. And what we've done at the main master hub site is we've taken all the overlay routes that are existing in our controller and redistributed them into the second MPLS provider. So we've been able to take that role of what that router was, in the old days was kind of doing between hitting both providers. We've been able to link that and strictly leaking out the overlay into the underlay of that second provider.
Or inter-AS VPNs.
Or if they were only internet only, and this is one of the use cases I'm going to talk about to talk about next. So now we've able to maintain that connectivity between both endpoints because that reachability is there from that layer 3 perspective.
The good thing about it also quality of service. When you do that.
Yeah. So we're able to add that as well also. Yeah. So. Overlay routing table, underlay routing table, and topology discovery is able to get us that on a sort of an accelerated path towards migrating into an SD-WAN environment. And what we have seen from another one of our customers is where they've elected to start migrating the branches first, and then the data center last. And this is because from what we've introduced as part of the new software is the capability to drop the underlay only, meaning behave as a traditional router. Forget about the overlay.
Anyway, they should do that. I mean, there will be migrated and non-migrated sites, and your hub site, which is data center, should be migrated last.
True.
Because they will be talking through data center. Migrated and non-migrated sites.
Yeah, very true. Yeah, so I mean that's been one of the safer approaches to introduce SD-WAN is that you come in, do your branches first, bring them on underlay only, have them operate, very much like a router replacement, and then when you bring in finally the data center, then enable SD-WAN, enable the overlay, and now you're able to utilize the full features of that SD-WAN. But many customers, what happened, and especially in what you were talking about, and what was very interesting is there's the impatience factor of network administrators, and where we get sort of that tunnel vision. Oh, I want SD-WAN, I want this for now, I want all this goodness. And they want to just jump into it and go fast in it. Oh, turn on every single feature. And that's what, in the past, has gotten in trouble. In that, you have to, this is why, some of the approaches as you're migrating is, maybe approach it a little bit slower, just be more careful about it, operate router only first, depending on what suits the model of, if the enterprise is going to it. So the next, so having that flexibility, it really is what we're going after, is to be able to, okay, what can I do from the old versus the new? So now that we know that we can manipulate all these routes, we wanted to, we had a new orchestrated approach into introducing internet as a transport. And what we've done with that feature, we're actually calling it a transit. We've made it easier for the end user to migrate from traditional MPLS as they're cutting over from MPLS into internet. So what we have, so that transit feature, what actually it does is at the very start of your cutover, the very first thing that you would configure is you would select your hub site to be the transit site. It's a one click, it's a one change that you do. As you're cutting over branches into internet only, the controller is made aware of that change. It knows that this branch is now on an internet only, and via the orchestration in the background, what it does is it takes those remote prefixes and starts to advertise them out of the master site into your MPLS for you. So now that connectivity from end to end is completed. Your traditional branches that remain on, via older, on MPLS, on the routers, on the traditional routers, they now know how to be able to get back to those internet prefixes, to those internet-only branches via the main hub site. All that is done for you. Automatically in the background, it's all orchestrated. Now, if you think about it, there's really no magic behind it.
Yes.
It's something that we've always been able to do for the past 20, 30 years. But what we have done is that we've orchestrated it for you, right? We have taken that section of code, if you will, and built it to be already pre-built. So you don't have to worry about creating the route maps, finding which prefixes I just cut over, redistributing them. And guess what? If you want to add on a second data center or a third data center, you can add them as secondary, tertiary, and those prefixes will be advertised out with additional prepends for you.
Prepend, you said?
Yeah, so we'll prepend those prefixes as
So you assume BGP?
Yes, exactly, yeah, assuming BGP. So, but that part of it, it's sort of taken that little bit of a, if you will, that AI that we have out there, and why not try to use it so we can now make that migration easier on the administrator. So it's one less change you actually have to worry about when on the night of the cutover. If you wanted to, you can actually just pass out the gateway to your to those remote sites. Okay, whenever you cut over, I'm going to guarantee that you're still going to be able to communicate with any of the other branches, and they're going to still be able to communicate back with you as well. So the branches can cut over at their own leisure, without having to making you be on standby, making sure now I got to make sure that now I got to change the route maps, being able to bring in manipulate all those routes, being able to did I forget a certain subnet, etc. The controller does all that for you.
You're really making it that you don't have to be a routing expert to make sure you don't blow things up when you add the second cloud, is really what we're getting at here.
Yeah, exactly. Which is really, if you think about it, that's the SD-WAN part that we've been looking for. Is that we're not necessarily asking everybody just hang your certifications or forget about those deep troubleshooting. No, but if something can actually go ahead and automate that for me, these low-end tasks, if you will, which I've done in the days of old, we used to just kind of copy and paste, right? But now there's something else kind of doing it for me. So give me that orchestration, use it, use that intelligence is out there, and do it for me.
You said for the overlay, we are running OSPF and BGP. If it's OSPF, let's say, and let's say 5,000 branches and couple prefixes are coming from each and every branch, then in that case, will you put all my prefixes in, let's say, backbone area, OSPF area 0, or automatically is the orchestrator placing the, let's say, branches in the non-backbone areas, or are you running BGP instead for the scaling?
Yeah, so one of the requirements for the transit feature is to be BGP attached to the provider. If you have any other routing protocol, then you can always drop back to a little bit more the manual way, if you will, of doing that redistribution, filtering, all just like the additional. We provide you those knobs to be able to do it yourself. If you're in such those environments.
I said because you might be needed to be a little bit expert in some cases. Yeah.
Yeah, it's there for yours to be used, right? If you need to. But if you happen to fit, which is part of that assessment, right, is that if you fit that profile, now a lot of those can be automated. So the second feature that we are introducing is what we call an alternate hub. Think of alternate hub sort of like a site of last resort for me. It's a use case that one of our customers, inquired about it, and we developed it. It's regarding when you have disjoint WANs. It's sort of like sometimes the missing feature because not all meshes are created equal, right? So imagine two different MPLS providers, Or the use case that we were that we considered it for is when you have your traditional internet running on DSL cable modem, whatever, and you have LTE. Physically, LTE and traditional internet, they're running. It's the same network. They can both connect to each other, right?
You can, yeah.
Yeah, but logically, we separate them out because the customer, for his business needs, wanted to separate out the LTE connections, the LTE uplinks, separately from his internet ground terrestrial-based uplinks, if you will. But he needed to make sure that connectivity is kind of flows between them. So when you have that logical separation, your internet terrestrial ground-based gateways, they're able to communicate. They're able to find out, okay, if you're this zone, I'm that zone, right? They've got that full mesh formed between them. But what happens for these zones, these networks that exist only off the LTE network? So the alternate hub is that it allows you to choose one of the hubs, one of the main hubs, to be sort of like kind of like my last resort. Hey, I know this network exists in my overlay fabric, but I just don't know how to get to it. So it's sort of like a default route, if you will, which, hey, send it to that hub. That hub knows exactly, because it has dual attachments to both LTE and traditional internet, is able to route that traffic between both. So just these are like simple little tiny use cases that we've been able to find and add solutions to them.
Well, there's another variant of this one because we're going through this now where we're migrating WAN transport providers. So we chose to fix it in the underlay because we have some control and we can route between the two providers and they'll let us. But the other way you do it is you have the cloud on the old, the cloud on the new, and you have to have that merge point
Yep.
to interconnect them. And I understand the point as you can only do a VPN between stuff that's on the same WAN transport.
Correct. Yep. Correct. Yeah.
So.
But it is alternate hub, you said. Is it passing traffic?
It can pass traffic. Yeah. So, for example, if you're going from a certain source to a certain destination, because inherently you've got it formed as a full mesh, you would expect that you would know about all the networks in that full mesh. But if you don't have that physical reachability to get you to that other destination, but yet you know that prefix actually exists in your overlay fabric, you just don't know how to get to it. So if you want to pass traffic to it, you can. You just have to do it through a transit point. And that's what that term, the alternate hub, is that it's not necessarily because you don't want to be in a hub. If it's a hub and spoke type of design, that's fine because everything has to talk to the hub. That's the easy portion. But what if you're in a full mesh, but you actually don't have a full mesh architecture to the remainder of those networks? And that's what that functionality serves to do.
Just wanted to check with you if that was possible for your solution to create an IPsec the tunnel with a third-party entity.
So on the quick answer is yes. We are able to form third-party tunnels to what we call classic VPNs to third-party tunnels. For example, traditional firewalls, traditional routers. As long as the algorithms are compatible, yes, it is able to. It's actually one. Hopefully, I'm not going into too much IP, but it's how we are able to connect to, for example, Zscaler. So they don't have, in Zscaler, they don't have our gateways in their sites, but we're still able to kind of form those tunnels.
Okay.